Welcome. I ran into a problem with one of my Spring Boot apps recently. It was a simple app, but I discovered that when I had a transactional test and I rolled back the transaction at the end of every test, that didn't roll back changes in the database that happened on the server. I was really surprised by this, and it really changed the way I think about this stuff. So I want to make sure you know about it and therefore know how to deal with it. So first I'm going to describe the problem. Then I'm going to show you this demonstration where tests do not roll back the way you think they're going to. And then I'll show you two mechanisms to fix it. One that's a little awkward, but one that I think I recommend for the future. So hang around for that and we'll get into the details as we go along. My name is Ken Cousin and this is Tales from the Jar Side. So here is IntelliJ IDEA with a simple application involved. Now, I'm going to go through the app in a moment, but let me just give you an idea about the architecture. Now, many architectures work in Java, obviously, and especially for Spring, but Spring naturally fits into the old classical three-layered architectural approach, meaning I'll have a presentation layer, and in my case, I'm just going to have a single controller for a RESTful web service at that point, no views on it. And then a service layer, which is where you would normally put business logic. Here I don't really have much business logic, but more importantly for our purposes, transactional boundaries. In fact, that's why I introduced the service layer, is so that I can actually bound transactions at the method level. And then in the back, I have a persistence layer whose job it is to convert domain classes into database table rows and back again. All very normal, very typical stuff. Now I'll come back to this service class in a few minutes, but let me show you some of the details now. So what I want to show you first is the actual product class. So here's the product class. I only have one class and one table. I mean, this is as simple as I could make it. This product class is an entity, and in fact, that's why I'm using a POJO rather than a record. I can't use records with JPA, and I'm going to do Spring Data JPA for my persistence with Hibernate. So this is a product class with an ID that is a long, and it's generated by the database, basically an auto number. I also have a name and a price, and the name is a string and the price is a big decimal, and they have a couple of constraints on them which aren't really important for this demo, but seem like a nice idea anyway. The whole rest of that class is constructors, getters and setters, toString method, and equals and hash code, all the normal stuff we've come to expect for POJOs being managed by Spring Data JPA. So speaking of Spring Data JPA, here is the product repository. This is one of the neatest parts about Spring Data JPA is that you just define the entire DAO layer by making an interface, here I called product repository, that extends one of Spring Data JPA's repository interfaces. You could start with CRUD repository, or these days there's list CRUD repository if you want to return values in a list, or I'm using this one, I'm using JPA repository, which stores products with a primary key of type long. This one line, frankly, would generate about a dozen methods automatically for me that complete pretty much everything I need in my DAO layer. Now, I did add another method, again, not really necessary for our purposes in this video, but just showing that if you follow the naming convention, you can have Spring Data generate the SQL for various finders for you and everything. Now, normally I wouldn't test a method like this or an interface like this. I mean, it's auto-generated code. As long as I wrote the interface in a way that compiles, everything should be fine. But what the heck, let's go look at a test. So I have this class called product repository test. And let me take this out for a moment. And this is a Spring Boot test. Now, I could have made it, for those of you who are aware of Spring Boot testing, I could have done what they call a slice test using data JPA tests. And that would be fine too, but I want to explicitly demonstrate what happens when I add the @transactional annotation to this. And more importantly, what happens when I don't have it. So the whole purpose of this is to auto wire in the repository and then test count and find by ID for ones that exist and for ones that don't potentially, and find all and inserts and deletes, all the way through. Now, where's my data coming from? I decided to keep it simple here as well. I actually have under source main resources a schema.sql defined to create the table for products right here, and a data.sql, which inserts 3 products into the table. So in general, I'm going to have those 3 products. That's also why I'm using the Spring Boot test in this particular example rather than data JPA test. I'd have to add additional code with that one to use that actual database. Now let's see what happens when this is not transactional. And you see I wind up with some failures. Not a big surprise. I mean, let's look at the order of these tests. First, I count them, and the count says, yeah, there's 3. And then I find them all, and I could print them or whatever, but I know there's 3. I could insert a product, and now there's 4, by the way. But here's the key. I just deleted all the products. I just emptied the product table. This did a select and then delete from, delete from, delete from, delete from. That's my first clue that something's not right here. I wound up deleting 4 products. Remember, I thought there were 3, but because it came after the insert, there's actually 4. And then selected count, yeah, there's 0, but that means when I deleted them all, when I hit find by ID, it says, no, there's no products in the database. Or if I try to do delete product with an ID, it goes, there's a 404. I thought there'd be 2, there's nothing, etc. Now, again, this one we know how to fix. This is the one where you add the @transactional annotation, and the way transactions work in Spring Boot tests, when you add @transactional to a test, then every individual test has a transaction that rolls back at the end of the test. And that keeps the tests independent of each other. So now when I run this test with all of those individual tests in it, everything should come out fine. And it does. And in fact, you could even see it. I've turned on certain logging so that at the beginning you could see began transaction 4, and then at the bottom rolled back transaction 4. And this is true of every single method. Began the transaction, rolled back the transaction. Now there's also getting and completed for the transactions on the actual service, but everything seems to be fine. We're rolling back everything. And this is the way I always taught it. It's like, yeah, of course, that you add your @transactional so that you can, in fact, test the interoperations with the database and have all the changes roll back. And you could even do things like I did down here at the bottom of deleting all the products and not restoring them because they all get restored from the transaction. Okay, so far so good. Now let's get into the problem. Now, first things first, here is my controller. Now, what I have here is a product REST controller, and it's annotated with REST controller. That's a regular controller that responds to various HTTP requests, but being a REST controller, what it does is if it returns any objects like products or a list of products, it serializes them into JSON data on the output. Good, all well and good, all very typical. I'm going to map all the methods to /products. And inside here, I have auto-wired into the constructor a product service. That brings us back to the service we were talking about earlier. Here's the service. It's annotated with that service, so it's a managed Spring Bean. And if you look at these methods, all they really do is delegate down to the repository. And the reason it's so simple is because I only have one class and only have one table that's being mapped to it. If I had a real service with a real e-commerce app, I'd probably have a whole series of DAOs, a whole series of tables, and the service is where I put my business logic so everything could run in a transaction across all of them. So the reason this looks so simple and even makes you question why I have the service at all is because I only have one table. But I still get a benefit here. The benefit is everything in here runs inside a transaction, and those transactions will commit when the method completes, unless we throw some kind of runtime exception or certain other cases. But in general, they'll all commit. Great, just what I want. So back to the controller. The controller has the service auto-wired in it, and now I have various mappings. Now I'm not going to go through these methods in detail. Let me just point out I have a get to return them all, a get to return an individual one by its ID specified as a path variable, a get to return the products based on a minimum price. Remember, I have that extra method in there. A get to retrieve the count. And here's a post to insert one in there and then set the location header to the location of the new product. And here's a put that does an update, assuming the product's in there, and a couple of deletes. One that deletes an individual product and one that's really dangerous, which would delete everything in the database. Again, you should put this behind a trusted security framework, as they say. Okay, all well and good. Now, what about a test for this? Now, I'm going to start off with a naive test. And what I'm going to do is say, all right, let's run a test through the Spring Boot test annotation on a random port. Now, this is a neat feature of Spring Boot. What it does is it starts up a test server, deploys your application to it, and then executes each of the individual tests and then shuts down the test server. And it will start up the test server on that random port. So really nice. And that's often how I test controllers in general, because it's a condition that closely simulates the actual reality of when I run this. But I'm going to have a problem. Now, because I've deployed this to a test server, I need a client, and Spring Boot and Spring actually provide a couple of different test clients for RESTful web services. This is the one called Web Test Client. The nice thing about this one, in addition to being a REST client, is it knows that random port. So I don't have to go setting the port or looking it up or anything like that. It'll automatically be able to invoke GET requests or POST requests or puts or deletes or what have you. So I have a couple of tests here. One to get all the products, and I expect a 200 back from that, and the body has a list of products, and I'll print them out. And here I'll do an insert. So I expect that the status will be a created, and there's a product in the body, and I'll print that out. Here I'll just get all the products with an OK, or get a count rather. And then here's my delete. That will delete them all. So I should get a no content from that. And then I could do a get to make sure that the count is 0. And then here's a find by ID where I've hard coded in a 1. Now that's already a little risky, but we'll talk about that more later. That should be okay. All right. So now let me run this and see what happens. And how about that? They actually passed. This is not necessarily a good thing. This fact that these tests passed is actually the cause of why I didn't realize the problem for several years. I got lucky. Now let me show you what the issue is here. Take a look at the order of these tests. Now, if you don't know, in JUnit 5, JUnit Jupyter, you don't necessarily know what the ordering is. In fact, here's what they say in the JUnit 5 documentation. In the section labeled 2.10 for test execution order in the JUnit Jupyter documentation, in the part on test execution order, it says, by default, test classes and methods will be ordered using an algorithm that is, and here's my favorite phrase in documentation almost anywhere, is deterministic, but intentionally non-obvious. Deterministic, meaning, yeah, it's the same every time, so you don't have to worry about it being random or anything. It's always going to be the same. But intentionally non-obvious. In other words, we're not going to tell you what it is because we don't want you to rely on it. Now, there is a way to order them. That's what this whole method order part is about, and I'll get to that in a moment. But the idea is that when you write your tests inside a test class in JUnit 5, you really don't know what order the tests will run in. And if you look at my tests now, these are not the order they appear in the class, and they're not alphabetical or anything like that either. So let's see what I got. Well, the count came first. And yes, there were 3 products in the database. And then get all, retrieve them all. And down here at the bottom, it's printing them all out and everything looks good. And then there's an insert, and it did in fact do an insert and retrieve and pulled back down here, the product with the ID. There's the updated product. But now there's 4 products in the database. So when I do a find by ID, all I had hardwired in was a 1, and there is a product with an ID of 1. We're good on that. And the delete came last. And that emptied the table. And we're fine because I don't know that there's a problem. In fact, there isn't a problem. Everything looks good. Yeah, okay. I got lucky. These tests are interacting with the database and modifying it. Now, you may have noticed these are not transactional. I didn't say at transactional, so I shouldn't be expecting any kind of rollback. Well, okay, let's fix that. And I'll put in the Spring transactional annotation one. There we go. And now let me run again. And now I'm expecting all of these to roll back. And the tests still pass, but the ordering means doesn't matter whether they roll back or not, we're still going to be okay. So if I really want to see a problem, let me actually specify an order. So from JUnit 5, I'm using the method orderer called method name. So they're going to order the test by the name of the test method. And let me run that. And now we're going to see our problem. Here's the issue. Delete in alphabetical order came second. And now all my products are gone. So the next one, which says find by ID, looking for that ID of 1, says, nope, there's no ID out there. And also kind of a subtle issue here, get all did a select statement for all of them and said, yeah, we got a 200 back, but there's no products. There's no error because I didn't do anything to test for the number of products. And then finally the insert happened at the bottom. So simply by jumbling the order a little bit, I find out, uh-oh, I'm in serious trouble. And the real problem is that at transactional didn't do what I thought it would do. Now, what's that all about? And this took me a while to figure out. If you look in the Spring Boot reference documentation, here's the Spring Boot reference documentation for the current version, 3.1. And you look under Core Features, Testing, and in fact, testing Spring Boot applications right here. They talk about how to test Spring Boot applications. And here in this note that's highlighted no less, in a note, it says, if your test is transactional, and my test is transactional, it rolls back the transaction at the end of each test. That's what I was relying on. However, and here we get the issue, as using this arrangement with either random port or define port, and I was using random port, implicitly provides a real servlet environment, the HTTP client and server run in separate threads and thus in separate transactions. Any transaction initiated on the server does not roll back in this case. And I didn't know it. I didn't realize that. Now, obviously, this is not a new problem. It's highlighted right in the documentation, but it's one of those cases where I thought I already understood it, so I didn't go looking at the documentation. I thought we were good, and we're not. When you roll back a test on the testing side, it does not roll back the modification of the database on the server side if I'm running on a random port. Okay, now you know the problem. How do we fix it? Well, there's two approaches to this. One would be the following. One would be to say, all right, let's restore the database each time so that I know there's going to be changes, but I'm going to reset it. That's a traditional way of fixing a test that modifies something that you're testing. So here again is my Spring Boot test on a random port, and I've auto-wired in my web test client. But what I did this time is I made my own list of products. And in my little setup method here, the one that runs before each test, is I'm going to delete all the products on the server side. I auto-wired in the repository itself, by the way, you notice, in order to be able to do that. Then I save all these products, and then I grab the IDs, because a lot of these tests down here actually go through each of the IDs and walk through them one by one. You know, I can go ahead and check everything. At any rate, this is the set of tests that restores the database each time. So let me run this one. And we'll see how that comes out. And we're good. Everything's fine. But it wasn't as easy to get there as I'm making it sound, because watch what can go wrong. I look at this, and if I was seeing it from somebody else, my first thought would be, wait a minute, you didn't make it transactional. At transactional again, okay? Just like we did on the other test. And chaos ensues. In fact, not only are these tests failing, some of them are having trouble even running at all. And the error is not necessarily obvious. Update here says, well, I mean, the error seems to say status expected at 200, but was a 404 not found. And I'm like, wait, what? What's going on? And get all products winds up saying, again, an error like, oh, well, actually, this one's a pretty good clue as to what's going on. We expected these 3 products that I added myself to contain, or expected the array list that came back to have those 3 products I added, but it had the old products in there. Wait a minute, what about the delete? The clue is to look at the delete itself, because the delete failing gave me the one piece of information I needed, which is this timeout trying to lock the table. Here's what happened. I made my test transactional, and my test is calling delete and save and find all on the server side. And remember, they're operating in separate threads. So what I've actually introduced is contention between the 2 transactions. I've got a transaction in my tests on all of these methods, and I've got transactions on the server side, and they're banging into each other. And sometimes they complete, but they get the order wrong. And it's a disaster. Everything's chaos. What I have to do, of course, is remove my @transactional annotation, and then again go back, and now I don't have contention anymore, and everything's running in the proper order, and we complete successfully. But I'm not sure I'm wild about this, because I'm not sure it's going to run successfully everywhere under these cases. I just know in this case, with only 1 class and 1 table and 1 thread, yeah, we're okay there. So that's a solution, but it may not be the solution. Here is what I consider to be a much better solution. Here is a test that says, you know what? Let's stop with this client and server thing running in separate threads. Let's go back to the old Spring Boot test annotation without a parameter on it, which runs in a mock environment. Remember, I needed that in the repository test to keep from interfering. And I'll throw in an auto configure mock MVC, not because I want to use mock MVC. You can, that's fine too. But the nice thing is it turns out when you throw on the mock MVC annotation, you could still auto wire in your web test client. And now these are basically the same tests. I mean, it's slight modifications, but pretty much the same thing. And when I make them transactional, now we're not in separate threads anymore. Now it's like the repository test, everything rolls back at the end of each one. You could actually see it. See, here's the began a transaction, and then at the bottom, rolled back the transaction, and everything is working just fine. So there's your answer. So the key concepts, let's summarize. The key concepts are when you run Spring Boot tests with a test server, meaning using a random port or a defined port, then transactions on the test don't control the transactions on the server. And if the server's dealing with a database or some other transactional entity, those transactions will not roll back just because the test transactions rolled back. Good to know. The ways to fix that are, one is to, okay, let's restore the database to its pristine form before every test. But now you can't make your test transactional at all, or you're going to wind up introducing contention where you don't want it. Or this approach, which is to go back to the mock servlet environment, if you will, and make those tests transactional, auto-configure mock MVC so you can inject in the web test client or a JDBC template or mock MVC if you want, and write your test that way. Now, I should finally note out of all this, the one piece of good news is my controller code was right. I mean, the thing I was testing is working. The controller and the service and the repository, they're all doing what I thought they were doing. My tests were the ones that were having problems. But don't let that discourage you from testing. In fact, I learned a lot about this from this whole process. And hopefully now that will help you as well. So you won't make this sort of problem anymore. If you like this content, I have a lot of other videos that are all going to be in the same area. I'm going to talk soon about how to use test containers, because in fact, this application was using a Postgres database maintained by Test Containers Cloud, by the way. And I'm also going to have a lot of other content related to Spring and many other areas as part of Tales for the Jar side. So please consider subscribing so you won't miss any of that content. Thank you very much for listening.